Hello and welcome to this quick demo of Tumult Analytics, the best-in-class framework for differential privacy. In this video, I'll show you what it looks like to use it to take sensitive data and generate insights that can be shared in a privacy-safe way. Say you're a data analyst at a large public library in a major city. You've been asked by the city council to produce a report on how the library is being used in order to discuss priorities to better serve the community and approve next year's budget. More specifically, the Council has asked you to answer those questions. How many members does the public library have? And which authors are the most popular among readers? What's the median age of readers of each literary genre? And more generally, how does reading behavior vary with age? The data about who uses the public library and what books they read is, of course, very sensitive. You want to make sure that whatever you will release cannot inadvertently reveal information about individuals who are library members. So you decided to use differential privacy, the gold standard for privacy-safe data sharing. In this first video, I'll focus on the first two questions, and show you what using Tumult Analytics is like by answering these two questions. In particular, I'll talk about the fundamentals of Tumult Analytics interface, its simplicity, robustness, and privacy tracking feature. We'll also see how it can protect individuals even if they contribute a lot to the data with something called privacy identifiers, and I'll show you a way to do group by queries in a privacy optimized way with public group by keys. Let's get started. So here, this notebook runs locally. I've installed both Tumult Analytics, which is a Python library, as well as PySpark, because Tumult Analytics is fully relies on Spark, so it scales to your very large clusters, but you can also run it locally. So first, we import what we need for the demo, and we're going to download some data and put it in Spark, like this. So as I said, the first data set we're going to look at lists the members of our fictional public library. So here we've got names, age, gender, education levels, so some demographic information, some information about how many books they brought and when they joined the library and so on. So let's answer our first query and figure out in a differentially private way how many members are in our public library. There's two steps to do that. First, actually 3 steps. We must initialize a Tumult Analytics session. Here we give it a name. We give a name to our sensitive data. This is the data that we loaded into Spark earlier. Then we say what we protect in the data. Here there's a single row per library member in the table that we loaded. So we're going to protect each row individually. And we're going to give a total budget that we can consume that protects each row in the database on this table. You can imagine the session is like a box. You put your sensitive data in, and then the session guarantees that everything that goes out of the box satisfies the privacy guarantee that's you specified at the beginning. To compute the statistic that we want, we're going to look at how many people are in our data first. So we're going to do that by building a query. Here we use a query builder that refers to the name of the table we added earlier here. And we're going to just count the number of rows like this. Then we're going to evaluate our query using a small part of the privacy budget, and it's going to give us a result here. So we know that there are approximately 54,000 people in our library. We started with a privacy budget of epsilon 1. We spent an epsilon 0.5, so we end up with an epsilon of 0.5. If we spend a little more, like 0.2, and we rerun the query, we're going to spend more privacy budget on our data. So if you look at the count here, it ends in 21. If I spend a little bit less privacy budget and rerun it again, I'm going to get another answer. Here, the noise added to the data to protect the statistics made that number vary. So this is sort of what differential privacy does. It gives you statistics that are approximately correct, but uses a little bit of statistical noise to provide very strong guarantees to the data. Here, after having spent 0.5 and 0.2, we end up with 0.3. And if we try to spend more, like 0.4 here, it's going to yell at us. It's going to tell us, no, you can't do that because we don't have enough budgets to answer that query. So this is how Tumult Analytics guarantees, the Tumult Analytics interface, the session interface, guarantees that you're not inadvertently using more privacy budgets and ending up with data that is less safe than you thought that you wanted to achieve. So that shows you the robust interface of Tumult Analytics, which sort of guarantees that your data has exactly the privacy property that you expect, as well as its privacy budget tracking feature. Okay, let's move on and look at the second query we wanted to answer, which is which authors are most popular. So for this, we're going to use another data set that instead of listing just the books borrowed by each library member, that instead of listing details about each library member, it's going to list all the books that were borrowed by library members here. So this is a sensitive table, of course. We don't want to reveal what books which person borrowed. And there's another table which is a public table, this one, which just lists all the books that are in the catalog of the library. So this is public information. You could maybe get that information from the library website. So we just want to protect the first one and not the second one. So let's download them, put them in Spark, and take a look at our checkouts dataset here. As you can see here, each row corresponds to a single event of one user borrowing a single book. So this is the member ID here of the book that was borrowed on this specific date. And there's some information about the book on the right side here. So we're going to load it in the session just like before. Whoops. We're going to load it in the session just like before, except something's going to change here. Before we were protecting each individual row. Now we're going to protect all of the contributions of any single member by telling the Tumult Analytics, telling our session initialization methods, what is the column that corresponds to, that identifies members. And then what Tumult Analytics is going to protect in that case is all of the rows that corresponds to the same member ID. So that corresponds to the same person who borrowed books. And we're going to give it the same budget as earlier, so epsilon equal 1. Of course, here I'm reinitializing session to show you how it works in different cases. But when you're running production, you typically only open a session once and you run all of the queries on your single session. So that's the basics of privacy identifiers, how you initialize a session with privacy identifiers. And now you can see who the most popular authors are using our group by query. So to build our group by query, we're going to use it using something we call public group by keys. So we're going to use our public database here of books, and we're going to list all of the authors that are present in this public table. And we're going to build something called a key set like this that says, here are all of the authors that people could have borrowed from the library. Then we're going to do a group by query. We're going to put these key sets, these group by keys, inside the group by clause here of our query to say we want to get one statistic per author presents in the books dataset. There's another thing that happens here before we count the number of books borrowed per author. We're also going to bound the total number of contributions from every individual user. So a single user could have borrowed many books, maybe 1,000 or multiple thousands. Differential privacy requires you to limit the contribution of any single here identifier, so here every single member. And so we do this using enforcing a constraint here to say for each member ID, we want to take at most 20 books in total to count towards the query. We evaluate the query like so, just like before, and then we can show the results. And this gives us the list of most popular author, which is probably about what you would expect from a public library. So that was it for privacy identifiers as well as public group by keys. Why are we using public group by keys here? We could also ask the session to find the list of possible group by keys from the private data, but then we would need to spend additional privacy budget to do so, and we would get less accurate results as a result. So this concludes the first part of this demo, where I focused on fundamental features and only gave you a glimpse of what Tumult Analytics can do. If you want to try it already, you can hop on over to this website here, tumult.dev, where you will find all the links to the installation instructions, tutorials, and the rest of our documentation. If you do give it a try, please join our Slack server, where you can ask questions, give us feedback or feature requests, and hear about new features before we announce them to the world. So, as I said, it was just the first part of the demo. If you want to learn more about what Tumult Analytics can do, you can click here, yep, like this, for the second part of this video, in which I run more complex queries to demonstrate some of the more advanced features of the framework. Thanks so much for watching, and see you in a couple of minutes if you look at the other video now.